Alrighty, hello again. Today we're going to talk about how to convert between the different types of linear equations we've done so far. Right, so we've talked about point-slope form, slope-intercept form, and standard form, right? And converting between these is actually pretty valuable, right? Sometimes one might be easier to work with in a certain situation than another one, right? Some of them are easier to graph than others, right? So converting between them is something that can be pretty helpful. So up top there, right, it's just kind of recapping what they are. So point-slope form looks like that with the y minus y1 equals m and then x minus x1 in parentheses there. So we won't often convert to point-slope form, right, because, it's usually one that we start with if we're grabbing information from a graph. But sometimes, pretty frequently we're going to convert out of point-slope form. Slope-intercept in the middle is y equals mx plus b, everybody's favorite. Right, so to get into slope-intercept form, the big focus is on getting y all by itself, right? We're solving for y, and hopefully our other side we can get to look like something that's sort of like mx plus b. As for standard form, right, this is the kind of odd one out, right? It's usually the one that, you don't always want to move yourself into, but it's still valuable to be able to do. It looks like ax plus by equals c, and the key part there is that all the x's and y's are on one side together, and then that c on the other side is just a number, right? So it's going to be all your variables on the left equals some number on the right. All right, so a lot of these we've already kind of done as we've been going through the notes for other types of linear equations, right? So a lot of this will hopefully seem pretty familiar, but it never hurts to get some more practice in. So to convert point slope to slope intercept, right? So that's y minus y1 equals m, and then x minus x1 in parentheses. Actually, let's go ahead and do this. Converting point slope, which is this one, and we want to turn that into slope intercept, which is y equals mx plus b. Right. So to do that, we're going to start off by distributing the slope m into the parentheses there. Right. After that, we're going to have some constant that we need to move away from y, and then we might have a little bit of cleanup to do. Right. We might have to take care of saying plus negative 5 and just turn it into minus 5. All right, so let's take a look. Right, again, something we've done in the past already. Hopefully seems pretty familiar. So to get this one into slope-intercept, I'm going to start by turning that 4 into something we're distributing into those parentheses there. All right, so on the left, you don't really need the parentheses around y plus 2 because it's all just by itself, so we'll drop those. On the right side, 4 times x is 4x. 4 times 4 is 16. All right. After that, what I need to do is I need to move the constant away from where the y is, right? So in this case, that's that plus 2 that's hanging on to it. So I'm going to have to do the opposite thing, subtract 2, in order to move that on over. And when we do that, we'll have y by itself equals 4x plus 14 on that other side. All right, so once we get to there, I believe that's it, right? I don't have to do anything with that last step where it's like clean up little messes like plus negative 5. Right, on this one, we're done. That's it. We're in slope-intercept form. Right, hopefully it doesn't seem so bad. Let's try this one out. Oh no, this one has a fraction. Already, I'm putting you through the ringer on this. So, same kind of steps that we're going to start off with, right? I'm going to take this 1/2, and I'm going to distribute it into those parentheses there. All right. When I do that, I'm going to move down to a new line. We're going to have y minus 3 equals, we're going to have 1/2 times x is 1/2 x. And then 1/2 times 4, right? Half of 4 is just 2. Okay. After that, we still need to move that number away from the y, right? So that minus 3 is going to have to go. The way we're going to do that is we're going to add 3 to both sides. All right, so we get y all by itself. On the other side, we'll have 1/2 x. And then 2 plus 3 is 5. Right. And that's it, right? That's all we got to do is we got that y all by itself. The other side looks like mx plus b, and we're good. So next thing we're going to talk about is how to convert, oops, I should probably zoom out so you can see the whole thing. Converting slope-intercept form, right? So y equals mx plus b, and turning that into standard form, which is our ax plus by equals c. Right? So our very first step is that we want to move all of our x's to be on the same side as the y's. right? So usually that's going to be by subtracting. Sometimes it could be by adding, right, depending on what your slope is. But you're moving all those x's to be on the same side as y's. And we're going to put them out front so that it kind of looks more like ax in the front plus by after that equals c. After that, we have two steps that we can sort of combine into one step if we wanted to. We want to cancel out any fractions that we've got hanging out by multiplying everything by a common denominator. All right, we'll take a look at what that looks like when we're going through a problem. Then, last but not least, if your leading coefficient, right, that a that's hanging on to the x is negative, you want to multiply everything on each side by -1, right? And we basically just want to be flipping it so that that leading coefficient is positive. To combine these last two steps into one big step, right, we would just multiply by a common denominator that's negative, right? It'll flip the negatives to be positives, and it'll get rid of the fractions. The reason I have them listed out as separate steps is because sometimes you might only have to do this one, right? Your leading coefficient might already be positive, right? Sometimes you might not have any fractions, and you just need to flip the sign, right? So you might only need to do that step. Right? There will be times where you'll need to do both. There might be times where you don't need to do either one, right? So let's take a look. So to go from y equals 4x plus 14 to something that's in standard form, what I'm going to do is I'm going to move all my x's to be on the same side as the y's. So that means in this case that 4x, I'm going to have to subtract it to cancel it out from that side. And I'm also going to have to subtract it over on the left side. All right, so when we do that, again, what I'm going to do is I'm going to put that minus 4x out in front. That y was positive, so we'll say plus y. And then on the other side, we'll just have 14 left over. All right. So after that, on this one, what I'm noticing is that leading coefficient is -4. I don't really want that to be negative. So what I'm going to do is I'm going to take everything, I'm going to multiply it by -1. Right? And all that's really going to happen here is that all the signs are going to flip to their opposites, right? Negatives will become positives, and positives will become negatives, right? But you can also think about it, if it's a little bit easier this way, as you're distributing -1 into each and every part. So -1 times -4x will give you positive 4x. -1 times positive y will give you minus y. You could also put in minus 1y, but most of the time you won't see that 1 there. And then -1 times 14 will give you -14. All right, so this is where we're hoping to get to, right? We want to end up with 4x minus y equals, -14. All right, that leading coefficient is positive. X's and y's are together. It equals just a number on the other side, and we're good to go. All right, let's try another one out. Ew, fractions already? Why would I do this to you? So, again, first things first is I'm going to move all my x's to be on the same side as the y's. So I have -2/3 x. I'm going to add 2/3 x to move that on over. And again, when I do that, I'm going to put them out in front. So I'm going to have 2/3 x. The y was positive y, so I'll say plus y. And then on the other side there, we're left with -5. All right, cool. So on this one, my leading coefficient is positive, right? So I don't need to worry about flipping it from negative to positive. However, it does have a fraction, right? So this is where we want to multiply by a common denominator. And the common denominator in this case also happens to be the only denominator, right? The only fraction is 2/3. So if we take all of this and we multiply it all by 3, that's going to cancel out that fraction. And some of the other stuff is going to change as well, but we're most interested in getting that fraction out of the way. All right, so when we do 3 times 2/3 x, again, all that's going to happen is it's canceling out the bottom there. So we're going to end up with just 2x. 3 times y is going to give us 3y. And then we do want to multiply to the other side as well. 3 times -5 is -15. All right, so this is what we want to go for, right? It's got a positive leading coefficient, and there aren't any fractions in sight. Right, that's really what we want to go for on this. Okay. One last one like this. Oh boy. This one might be a little bit of a doozy, but let's talk it through. So what we're going to do is we're going to start by moving those x's over to be with the y's. Right, so again, I'm going to subtract 7/4 x from both sides. All right, so we'll have negative 7/4 x. The y was positive, so we'll say plus y. And then on the other side, we're left with just a positive 15. All right, so this one's real gross, right? Not only is our leading coefficient a negative number, it's also a fraction. So the way that we're going to get rid of that is we can combine those steps into one big step, right? Remember I was talking about, we can get rid of the fraction and flip to positives all at the same time. So what I'm going to do is I'm going to take that that common denominator we would normally multiply by, which in this case is 4. I'm going to slap a negative sign on it. Right, so again, what that's going to do is it's going to both get rid of the fraction and make that leading coefficient positive all in one step. Right? You're welcome to do it as two separate steps if you want to, right? You can multiply by 4, get rid of the fraction, and then multiply by -1 after that and flip the signs. Right? Whatever works for you. I am going to run through it like this because I do think, having to do a little bit less is not a bad thing. Right? So when we're going through and multiplying everything by -4, when we multiply it into negative 7/4 x, the denominator will cancel the bottom of the fraction, and then negative 7 will leave us with positive 7 with that x there. All right. When we do -4 times positive y, we're going to end up with negative 4y, and then -4 times 15 will give us negative 60. All right. So again, if you feel more comfortable doing these one step at a time, that's perfectly fine. There's nothing wrong with that. It's the exact same thing. Sometimes getting it down to be one fewer step is pretty nice because then you have less that you need to do, right? But whatever works for you, do that. So something else you might need to do on the next page there is convert from standard form, right? ax plus by equals c. And we might want to turn that into slope-intercept form, y equals mx plus b. All right. The reasons that we might want to do this is that, slope-intercept is much easier to graph than standard form. Right? So to do that, what we want to do is we want to move our x's to the opposite side, get them away from the y's, right? So that hopefully the other side looks something like mx plus b already. Then we want to divide each side by the coefficient that's attached to our y in order to get that y by itself, right? Remember that when we're trying to get it into slope-intercept form, it's like we're just solving for y. After that, we might have some fractions left over. If they do simplify nicely, we do want to simplify those, right? Don't leave 6/2 as 6/2. Change it to 3, right? 6 divided by 2 is 3. If you have any other fractions, like say you have 10/50, right? Change that into 1/5, right? It's not like it's a good habit to get into. It'll make your life a little bit easier as we keep on going. So to convert from standard form to slope-intercept, right? Again, all I want to do is I want to get that y by itself. So now I have 3x plus y equals 7. What I'm going to do is I'm going to move those x's away from the y. I'm going to subtract 3x from both sides. When I do that, just like when we were working on some other problems, I'm going to do something that might be a little funky. So those 3x's canceled. We're left with just a y over on the left side. And I'm going to take that negative 3x and I'm going to put that out in front of the 7, right? So we'll have negative 3x. That 7 was positive, so we'll say plus 7. Right? And the reason I'm doing that is so that it looks more like y equals mx plus b, right? I want that mx to kind of go out in front of where my y-intercept is. All right, so that's what we're going to be doing on these, is we're going to kind of scooch that right on in there. And let's try another one out. On this one, again, same deal. I want to start by moving those x's away from where the y's are. All right, so I'm going to add 4x to move that on over. All right, when we do that, they cancel out from the left, and we're left with negative 2y over there. On the right side, again, we're going to squish that 4x in front of the 18. So it was a positive 4x, so just leave it as regular old 4x. The 18 was positive, so we'll say plus 18. Yeah. After that, we want to get rid of that coefficient that's on the y. So that negative 2, we got to get rid of it. The way that we're going to do that is we're going to divide by that coefficient, right? Remember what we were doing when we were solving multi-step equations? Right, so divide by negative 2, and And when we do that, we want to divide everything on the other side by -2 as well, right? The way I'm writing it might seem a little bit weird, right? You might be thinking like, well, why don't we just write it like this, right? That's the same thing, right? We can do it either way. I like to break up the division like this so that it's a little bit easier to think through. All right, 4x divided by -2. And then a little bit later, 18 divided by -2. Right? Whichever way you want to write it, they mean the same thing. Either way, what we're going to have is that those -2's cancel each other over on the left. We're left with just y. Over on the right side, 4 divided by -2 is -2 with an x attached. And then 18 divided by -2 is -9, so we'll say -9 there, right? And this is what we want to get to right over here. Right. Cool. So y is by itself. We have mx plus b sort of looking thing on the other side, and that's it. If you haven't tried one on your own yet, maybe pause here, try this one out, see how it goes. All right. Hopefully you tried it out. If it didn't, if you got a little bit stuck towards the end, that's okay. Some of these are a little bit tough. All right, so first things first, I'm going to move those x's away from the y's. So I'm going to subtract 2x from both sides. It's going to get rid of them over there. And we're left with -4y. On the right side, we're going to squish that -2x in front of that +8, just like before. After that, what I need to do is I need to get rid of that -4 that's multiplying that y. So we're going to divide by -4. And again, I'm going to go ahead and do that to everything on the other side as well. All right. When we do that, those -4's cancel each other out. We're left with just y. Over on the other side, ooh, this is where the fractions might rear their ugly heads. We have -2 divided by -4. All right, so how about let's just take a second. Let's leave it just like that. So -2 divided by -4 with an x. After that, we have 8 divided by -4, which will give us -2. And so this is what I'm talking about when we might want to simplify any fractions that we can at the end. If I have -2 divided by -4, right, isn't that the same thing as +2 over 4? Right? Those negatives will cancel each other out. And then I could go even one step further, right? 2 divided by 4, right? 2/4 is the same exact thing as 1/2. Right? So ideally, we want to get to this point, right? Y equals 1/2 x minus 2. If you left it with 2 over 4, you're not wrong, right? It's one of those things where, you could take more steps to it, but it is really good to do those extra steps, right? You want to have your answer as simplified as possible so that if you need to use it for another problem, it's going to be a little bit easier to work with. All right. So we've taken a look at converting most of them to the other ones. The one last one, right? There aren't any particular steps because it's kind of an amalgamation of everything we've been doing so far. So we want to convert from point slope form to standard form. Ooh. So there's a couple of steps that we're going to take as we do this. All right, we are going to go from point slope, and we are going to convert ourselves to slope intercept. And then after we get to slope intercept, then we are going to turn ourselves into standard form. All right, so there's multiple steps that we're taking here. So go from point slope to slope intercept first, right? What I know I need to do is I need to go ahead and distribute that slope into the parentheses to help me get rid of that. All right, so let's do that first. So 4 is going to multiply into x and into that other 4. So I have y plus 2 equals 4x plus 16. I think this might be the same problem that we started off with, right? And that's okay, right? So we know that we can do it. After that, what I need to do is get that y by itself. So I'm going to subtract 2 from both sides. Okay? So after that, we're going to have just y over there. The 2's are gone. And the other side's going to look like 4x plus 14. Cool. So we started in point slope form. Now we're in slope intercept form. Right? After that, we still need to get ourselves into standard form. So to get it into standard form from here, I need to move all my x's to be on the same side as the y's. So in this case, that means I'm going to subtract 4x from each side. All right. When we do that, again, I'm going to put the negative 4x out in front of that positive y. All right, just so it looks a little bit more like ax plus by equals c. On the right side, those 4x's are gone, and we're left with just a 14. You know, this one also looks like number 3, right? That's what that little note was for. Take a look at 1 and 3 if you get stuck. We're just kind of smushing it all together into one big problem. All right, so to get it all the way into standard form, right, I don't want that leading coefficient to be negative, right? So that negative 4 is an issue. To get rid of that negative, what I'm going to do is I'm going to multiply everything by negative 1. When we go ahead and do that, right, negative 1 times negative 4x is positive 4x. Right, negative 1 times positive y is negative y. Right, again, the 1 that you could put in front of there would be correct if you wanted to do it, but it's optional. You don't need it all the time. And then on the other side, negative 1 times 14 is negative 14. All right, and all of a sudden, we've made it to standard form. Right? Hopefully doesn't seem like the absolute worst thing we've done. You know, I'm not going to say it's fun, right? But you know, at the end of the day, we're using steps that we've practiced already. We're just kind of putting them all together. Right? So, I know this is a big ask. What I'd like you to do is try out number 10, right? Try and turn this all the way into standard form. All right, so pause here, give it a shot. If it doesn't go well, you know, you got plenty of space. You can follow along with me afterwards, but see if you got it. All right, so, hopefully you tried that out. What I'm going to do is I'm going to start off the same way. I'm going to take this slope and I'm going to distribute it into these parentheses. All right? If this multiplying with the fractions was the part that tripped you up, please, you know, pause after that and then try the rest from there, right? So let's talk about this part, right? Y plus 7 is still going to be y plus 7. 2/3 times x is just 2/3 x. And then 2/3 times negative 6. Let's take a look. 2/3 times negative 6, which we can put over 1. Oops. You multiply the tops together, so you get 2 times negative 6 is negative 12. 3 times 1 is 3. And then negative 12 divided by positive 3 is negative 4. Right? So when we're doing that distribution there, we're going to get 2/3 x minus 4. Okay. So from here, what I want to do is I still need to get myself into slope-intercept form along the way. So I'm going to move that 7 away from where the y is. In this case, that means I'm going to subtract 7. Okay. So we're going to get that y is equal to 2/3 x, negative 4, take away 7 more, brings us down to negative 11. All right, cool. So, again, we started in point slope. We've now made it to slope-intercept. We got a little bit more to do to get ourselves to standard form. To get to standard form, I need to move all my x's to be on the same side as the y's. Actually, let me zoom in a little bit. So to get those x's over, I need to subtract 2/3 x from both sides. Yeah, so we can get negative 2/3 x. We're going to put that out in front. And then plus y, right, because that y was positive. Over on the other side, we have just negative 11. So we're getting closer, right? All my x's and y's are on the same side, but I've got a negative fraction as my leading coefficient. Oh, the worst of the worst. So what we're going to do to get rid of that is we're going to multiply everything on each side by that common denominator. And then if we wanted to be fancy and flip the sign to be positive at the same time, we would make it a negative 3 that we're multiplying by. All right, so let's give that a shot. So negative 3 times negative 2/3, right? The negatives will cancel each other out, so I'll end up with a positive. The 3's cancel each other out, so we're left with just 2 and that x attached to it. Negative 3 times y in the middle there is going to give us negative 3y. Then on the other side, negative 3 times negative 11 is going to give us positive 33. All right, so that's where we want to get to on this one, right? That leading coefficient is positive and a whole number. All right. So again, I'm not gonna lie to you and say like, "Oh, these are so much fun." They're kind of fun to me, but you know, that is what it is. Right? But hopefully they don't seem super duper bad, right? I know this is a bit of a short one compared to some of the ones we've had recently. So be sure to check on Google Classroom for any additional stuff I might be having you do. I believe that we might have an assignment that I'm going to assign with this one, but be sure to check on there and see what's up. And if you have any questions, please ask them. Send me an email, ask me when you see me in person, either way. But for now, I will see you next time.